exome. In the case of SomaticSeq, let's consider how you could switch each of these out to achieve one objective or another. So let's say you want to create a SomaticSeq classifier that you're going to apply to samples in the future. So you would use, for instance, for your data input, you would supply the tumor and the corresponding normal BAM file. Because you're creating the classifier, you also need to supply ground truth in the form of a VCF file that represents the true positive. The tools that you use, they could be the 5 variant callers that Litai discussed earlier. We have an additional variant caller, somatic indel detector, that you can choose from. So let's say you choose all 6 variant callers and the SomaticSeq trainer that's going to create your rule set. Associated with each variant caller will be the settings for each of those. And then the resource bundle will include perhaps GRCH38 reference genome, a corresponding bed file, and dbSNP. Now, if I change my objective, and let's say I ran this workflow and created a classifier, I will, for instance, as an input, provide new tumor normal over which I will run the SomaticSeq classifier, so changing out the input. And then for the workflow, in addition to running the 6 variant callers, I'm going to also select or choose to run the SomaticSeq classifier. The parameter settings will match the ones that I chose when I initially trained the classifier. So perhaps when I first ran this workflow, I saved it with the associated parameter set, and I'm just modifying certain portions of that workflow, but not the parameter set when I'm going ahead and running the classifier. The classifier that was created during the first workflow will actually now be part of, called a classifier rule set or a somatic model, and will be saved as part of the resources bundle. So I'm also switching out the resource bundle here. So that kind of flexibility in the genomic management solution allows you to do a lot more. Now let's see what the GMS interface looks like. I'm going to focus in on what I was just talking about, the resource bundles, parameter sets, workflow, and tools. In the resource management section of the Bina GMS, you can see, for instance, here, specific tools are selected. So we see some SomaticSeq tools and some others. In the parameter sets are the settings associated with each of the tools. So we see in this window, for instance, a parameter set associated with that would be associated with GATK, one that might be associated with, for instance, CREST, and another for control freak. These are all different tools, and now we have the associated settings that you would potentially select when you ran a workflow. Then are the resource bundles. And what we've tried to do in Bina GMS is actually create a number of default resource bundles that potentially for many of your workflows will include all of the resources you need. And so, for instance, for HG19 and different versions of the reference genome, we have associated resource bundles. And then finally, the workflows. So, for instance, here you'll see workflows for DNA-seq, RNA-seq, and the somatic workflow. You'll see some of these are identified as Bina certified workflows. These are workflows that we've vetted and worked with extensively, and you can go ahead and clone these workflows and change your particular settings to as you desire. So if I go ahead within Bina GMS and select the somatic workflow, here's what your workflow page will look like. This is the top of the window, and then we'll see what the top looks like and scroll down. But as you can see, the first thing you do is you can select the number of workers or nodes that you would choose to run the workflow on. And then for input, we're going to select a resource bundle and the data input. And so for SomaticSeq, I can go ahead and select the one with the corresponding the reference genome I work for. I want to work with. When I'm going to run the classifier, I don't need to include a resource bundle that contains a classifier. The first time I run through this to create a classifier, it's just going to use the reference genome, the bed file, dbSNP, and so on. Then I'm going to select data. When I'm going to run a classifier, I'm going to need to specify the tumor and normal BAM files and a VCS file corresponding to the ground truth. So that's where I'll go ahead and do that. And then after training, when I go ahead and run the classifier, at that point, I'll only need to specify a tumor and normal BAM file. Looking down further in the somatic workflow screen, here's in the top now of the window where I'm going to choose to save the results of running the workflow. And subsequently further down are the choice of variant callers. You see here that there's going to be, when I go ahead and click on a specific variant caller, this drop-down will appear, which will then allow me to choose the parameter sets of choice corresponding to that variant caller. So typically, you may choose to actually run all 6 variant callers to leverage all of those results for your classifier. Now, in some of these cases, we've actually fixed the settings as well, so you may not need to choose a parameter set. Going further down here for consensus calling, this is where I'm going to make my choice of whether I'm going to create a classifier by choosing Train SomaticSeq. I'm going to run using an existing classifier, or I'm just going to run the variant callers that I've selected above, doing a simple consensus calling. There are also parameter sets associated with SomaticSeq, and so those get selected in the middle of the window.